Hello everyone and welcome to the lecture number 9 of Engineering Mechanics. In previous lecture we have discussed about equilibrium, static equilibrium, dynamic equilibrium, general equations of equilibrium and free body diagram. In today's lecture we are going to learn about Variance Theorem. So let's start. Variance Theorem. It states that if a number of coplanar forces are acting simultaneously on a particle, the algebraic sum of the moments of all the forces about any point is equal to the moment of their resultant force about the same point. To understand this theorem, let's suppose there is a body on which, let us say, three forces F1, F2 and F3 are acting. And here is the point P about which we have to calculate the moment of all these forces. So now the moment about P of this force system is given by, let us say, the moment due to force F1 about the point P. Let us say this is mF1. Similarly for the F2 this is mF2, and for force 3 it will be F3. Now the moment at point P due to this force system is the algebraic sum of the moments of all the forces, that is F1, F2, F3 about the point P. Now let eliminate this whole force system and substitutes by the resultant of this force system. Let us say, again we have to take the body, same body, and let us say this is the resultant force of this force system and this is the point P. Now the moment of the resultant force about the point P, let us say moment at point P of resultant force is given by, let us say, mR. So according to this Variance theorem, it states that the moment at point P due to force system is equal to moment at the same point P due to resultant force. This is Variance theorem. Now let's take an example to understand the concept of this Variance theorem. We have a question here. A horizontal line PQRS is 12 meter long, where PQ is equal to QR is equal to RS is equal to 4 meter as shown in the figure. Forces of 1000 Newton, 1500 Newton, 1000 Newton and 500 Newton act at point P, Q, R and S respectively with downward direction. The lines of action of these forces makes angles of 90 degree, 60 degree, 45 degree and 30 degree respectively with PS. PS is the line. Find the magnitude, direction and position of the resultant force. So first we have to find out the magnitude of the resultant force, which is given by under root of sigma h square plus sigma v square. Now we have to resolve all the forces into two components. We have to resolve all the forces into two components, horizontal and vertical component, and then take the algebraic sum of the vertical forces and horizontal forces, and then we have to put those values into this formula to get the value of resultant force, magnitude of resultant force. So let's calculate sigma h. Sigma h will be given by all the horizontal components of the forces. Let's say this is 500 Newton force acting 30 degree with the horizontal. When we resolve this force into two components, sigma h and sigma v, then this will be 500 cos 30 degree, and this will be 500 sin 30 degree. Similarly for this, and this is already at 90 degree, so it is only vertical, no horizontal component is available for this force. Now while calculating sigma h, as the direction of all horizontal components are in this direction, so it will be taken as negative. So first force is this one, so minus 500 cos 30 degree minus 1000 cos 45 degree minus 1500 cos 60 degree and minus 1000 cos 90 degree. Upon solving all these values, we will get sigma h is equal to minus 1890 Newton. Similarly, we can calculate sigma v, and sigma v will be equal to 500 sin 30 degree. Again this will be in minus cause all the forces are in downward direction, taken as negative. Minus 500 sin 30 degree minus 1000 sin 45 degree minus 1500 sin 60 degree minus 1000 sin 90 degree. Upon solving this, we get sigma v is equal to minus 3256 Newton. Now we have the value of sigma h and sigma v. Then put this value in this formula, under root sigma h square plus sigma v square, and we will get force as 3765 Newton. So this is the magnitude of the resultant force of this force system. Now next is the calculation of the direction of resultant force, which means the angle. The theta will be given by tan inverse sigma v upon sigma h. Again putting the values of sigma v upon sigma h, we will get the theta is equal to 59.8 degree. Now it says that a resultant force of magnitude 3765 Newton is acting in the direction making angle theta 59.8 degree with the horizontal. Now let us say that somewhere here is the resultant force making an angle theta. Now we have to find the position of this resultant force. So here we can apply the Variance theorem to calculate the position of resultant force. Now first, taking the moments of the vertical components of the forces and the resultant force about the point P, and then equating it to the moment of the reaction force about the point P. So taking the moments of all these forces about the point P, it will be, let us say, moment at point P due to forces is equal to 1000 into 0. This is a force which is already passing through the point P. So the perpendicular distance from this point P is 0. Now similarly for this 1500 Newton, and we have to take only the vertical component of this force, so it will be 1500 sine 60 degree into 4 plus 1000 sine 45 degree into 8 plus 500 sine 30 degree into 12, and the moment at the point P due to resultant force will be given by magnitude 3256 into x. Here we have taken only the vertical component of the resultant force. Now equating these two, which means MPF is equal to MPR, we will get x is equal to this whole equation divided by 3256. So upon solving, we will get 13852 divided by 3256, which is on further solving we will get 4.25 meter. So now the distance x is 4.25. So at the distance of 4.25 from the point P, the resultant force will act. So this is the Variance theorem. Happy learning.